Hey everybody, so in this video I'm going to be showing you how to represent a number that's in binary but in its negative form. So negative numbers in binary, we're going to be using this method called the 2's complement. And so it's pretty much a two-step process. You're first going to take the complement of each digit one by one. So if you have a 0, you make it a 1. If you have a 1, you make it a 0. And then you take the sum of that number that you got from this step 1, and 1. So let's just do an example. So we have the number 5 that's in decimal form. Okay, I put that little subscript 10. So 5, we're going to represent it, or I should have said negative 5. So negative 5, we're going to write it in binary. So to begin with, 5, positive 5, that would be written this way. So let's put this header on top. So 5 would be 1, 0, 1, 0. The way you check that is you would pretty much add these numbers. So you have 1 times 1 plus 4 times 1. Take the sum of those and you get 5. So anyways, this is 5, positive 5 in binary. And we're going to apply the 2's complement procedure. So to begin with, as I said in step 1, we're going to take the complement of each digit one by one. So go ahead, because we're using right now here a 4-bit. So that's why we have 4 digits. Let's say if we were using 3 bits, you would only have 1, 0, 1. But anyways, we're using 4 bits. And the amount of bits are really important because you can't represent the number negative 20 or negative 10 or negative 12 in 4-bit. You need 5 bits. So anyways, let's just go on with this example. So we wrote down positive 5 in binary. We're going to take the complement of every single one, and that would be 1, 0, 1, 0. So if there was a 1, made a 0. If there was a 0, we made it a 1. Okay, and now we're going to add the number 1, which is 1. Pretty much just add them. 0 plus 1 in binary, that's 1. 1 plus 0, 1. 0 plus 0, 0. 1 plus 0 is 1. And that's our number negative 5. Oops. That's our number negative 5 in binary. Okay. Right. So we just added these two numbers. And then we got this number negative 5. So we're going to go ahead and add a positive number with a negative number in binary. So let's say we want to do this this calculation. We want to do 7 minus 2. We already know the answer is 5, but we have to do it in binary. So what we're going to do is not 7 minus 2, but the same equivalent form, 7 plus negative 2. Okay, so we're going to keep 7 in its positive form, and then we're going to rewrite the number 2 in negative form. So, okay, we know 5. So 7 in binary would be using 4 bits, 0, 1, 1, like that. All right. And then the number negative 2. So we want to write 2 in negative form, negative 2. So 2 we know is 0, 0, 1, 0, okay, like that. And then we're going to take the complement, like I said, the first step. That would be 1, 1, 0, 1. And then we're going to add, okay, so now we're done with that part. Now we're going to add the number 1. Okay, 1 plus 1 in binary is 0. We carry a 1, so we have a 1 here. 1 plus 0, 0, so that's 1. 1 plus 0, 1. 1 plus 0, 1. Okay, so this right here is a negative 2 in binary. Okay? I could put a sub 2, meaning it's in binary, but whatever. So now we have 7 right here, positive 7. Okay, so this is plus 7. And then we have a negative 2. That is, I'm just going to copy that number that we found. And then we're just going to add these two. Okay, like I said, I have 7, and we're going to add it with negative 2. This is 7, this is negative 2. We're going to add those two numbers. And then we get 1. 1 plus 1 in binary, 0, carry the 1. 1 plus 1 plus 1 is 1, and we carry a 1. 1 plus 1, that's 0. And then, since we're using 4 bits, right, so as I said, 1 plus 0 plus 1, so that's 1 plus 1. It would be 0, and we carry a 1. Okay, so we carry a 1 here. And then it just drops down to be 1. But we're using 4 bits, so we could just ignore that. And this is our answer. So we have 0, 1, 0, 1. Now, how do we check that if it's right? As I said before, the number 5 in binary is 0, 1, 0, 1. And what did we get? We got 0, 1, 0, 1. So, so checking our answer should be 5. And this number in binary is equal to 5 in decimal. So that's pretty much it.